Hello, my name is Aria Lipker. I am a freshman, a rising sophomore, and I want to be a chemistry LA because of my own experiences with chemistry. In high school, I was an AP chemistry student, and I felt like I was constantly falling behind. The way my teacher was explaining things, I just didn't get it, and I felt like I had to keep memorizing and memorizing to keep up with the tests. And I grew to resent chemistry. So when I came to UNC at first, I was terrified knowing that I'd have to take a lot of chemistry. And on the first exam, I did pretty poorly, honestly. So I was just really stressed and freaked out. So I went to talk to my teacher, and she gave me some suggestions on how to improve, and we went through my test. She also told me to go to these peer mentor sessions. So I went to one peer mentor session, and I could already see my growth in understanding the topic. So I felt like that was something that was really great, and I wanted to do that for someone else. So to help students study for chemistry, one thing I would suggest definitely not to do is just passively reading the textbook and trying to memorize, because that is what screwed me over. I think some methods that would help me at least, are spaced repetition, so making sure you don't cram at the last minute and try to keep going and building up on things. Making diagrams and drawing out topics, or trying to explain the topic to someone else, or at least talk about it out loud. I feel like those things help it stick better for me. And now I will do a sample problem for Chem 102. During vigorous exercise, lactic acid builds up in muscle tissue. A 10 milliliter sample of 1 molar lactic acid is titrated with 1 molar NaOH. Calculate the pH when 5 milliliters NaOH has been added. So first things first, what I like to do is write out all my information so I can see what I have and what I need to look for. So in this case, that's pH. So first, let's write our equation. So we have our acid, and then OH minus for the NaOH. And we're going to be using a one-way arrow because we know OH minus is a strong base and this reaction will go to completion. Then we have a conjugate base and water. So we need to figure out our initial. So to do that, we can do 1 molar, 0.01 liters. We have 1 moles, so we can write that out in the initial. And then we can do the same thing for NaOH using the amounts that we've been given. And we'll find that's 0.005 moles. Start with 0 over conjugate base, and water does not count because it is a liquid. So now we have to subtract, and we will subtract by 0.05 moles for OH minus because that is the limiting reagent, and this will go to completion. And we'll add by that much on the conjugate base side. So we're left with 0 of the OH minus and 0.05 moles of both the acid and the conjugate base. So when we look at this equal amounts, we can automatically think that, okay, we're at the midpoint because our acid and conjugate base amounts are equal. So now, since we started with lactic acid, which is a weak acid, and we have a base, we should automatically be thinking buffers. So we're going to use the Henderson-Hasselbalch equation, which is written right here below. Okay. So, with our second half of the equation, we know that our concentration of the conjugate base and the acid are equal. So this will leave us with a log of 1. And when we know we have a log of 1, that equals 0. So this part can be canceled out. So we know we're just going to be left with our pH equaling our pKa. So to solve for our pKa, we can look at our Ka here. And we know that pKa is equal to the negative log of the Ka. So since our Ka was equal to 1 times 10 to the negative 4, our pKa is going to be equal to 4. So our pH will equal our pKa. So our pH is 4.